So, you clicked on this video expecting Calculus 1, Lesson 1, but instead you're looking at Fortnite Save the World. Don't click away, it's still Calculus 1, I promise. But let me ask you a question first. How do you describe something that's always changing? How do you know the exact speed of a car at this instant, not the average over a mile? How do you calculate the exact growth rate of a population or predict the spread of a virus? Algebra cannot do that. Geometry cannot do that. But calculus can. In fact, calculus is everywhere. Every time you check your phone's GPS, launch a rocket, or watch a 3D animation like Fortnite, calculus is working behind the scenes. By the end of this lesson, you'll know what calculus really is, why it was invented, and why it's considered the most powerful tool in all of mathematics. So, you may be wondering, what is calculus really about? Let's strip down calculus to its essence. Calculus answers two questions. One, how fast is something changing at an exact instant? And two, how much total change happens over time? These two questions gave birth to the main branches of calculus. Differential calculus deals with instantaneous change. The key tool here is the derivative, which measures the slope of a curve at a single point. And integral calculus deals with accumulation. Imagine adding infinitely many tiny pieces, like finding the exact area under a curve or the total distance traveled from infinitely many speed snapshots. That's what an integral does. Here's the beautiful part. These two ideas are deeply connected by something called the fundamental theorem of calculus, but we'll get to that later. So why should you care about this? Because calculus models the real world better than any other math tool. Think about motion. You're driving. Your speedometer shows 60 miles per hour. That's not your average over an hour, it's your instantaneous speed. That number comes from the derivative of your position over time. Think about science and engineering. NASA uses calculus to calculate rocket trajectories, fuel optimization, and planetary orbits. Economists use it to predict supply and demand and maximize profit. Doctors use it to model drug concentrations in your bloodstream over time. If you can measure change or accumulation, calculus is definitely behind it. Without it, modern science and technology probably would not exist. Was algebra not enough? Before calculus, math could only handle static problems like shapes, distances, and constant speeds. But what about things that can accelerate? How do you measure the exact slope of a curve at one point instead of across a whole section? In the 1600s, two geniuses, Isaac Newton and Leibniz, solved this problem independently. They invented calculus because the universe doesn't stand still. Planets move, objects fall, economies fluctuate, populations grow. Things can accelerate or change. They needed a language for this change, and calculus became this language. Funny enough, Newton invented calculus while trying to understand planetary motion, which led to his laws of physics. Without calculus, modern physics would not exist. Without physics, no rockets, no GPS, no internet. That's how big calculus has become. The foundation, limits. Everything in calculus starts with a single idea, the limit. What is a limit? It's asking what value do we approach as we get closer and closer to a point, even if we never actually touch it. Imagine a car moving along a curved road. We want the speed at an exact instant. Algebra says take 2 points and find the slope. But if you want the slope at just 1 point, the second point disappears. That's impossible. Unless you imagine the second point getting infinitely close. That's a limit. And once you understand limits, you unlock derivatives and integrals. So in the next lesson, we'll deep dive into limits because they're the foundation of everything calculus related. Let me show you why this is mind-blowing. Calculus doesn't just describe change, it predicts the future. In physics, derivatives let us predict where an object will be next. In economics, integrals help calculate future profits. In medicine, calculus predicts how a tumor grows so doctors can act early. Every engineering design, from skyscrapers to airplanes, relies on calculus. If you've ever used Google Maps, the shortest route you took was calculated using calculus. If you've seen Pixar movies, those smooth curves and realistic motions in their animations are all powered by calculus and linear algebra. So, here's the big picture. Calculus is the math of change and accumulation. Two main branches, derivatives and integrals, and limits are what makes them possible. In the next lesson, we'll tackle limits, the heart of calculus. If you can master limits, derivatives and integrals become way easier and will help you build the foundation for these two. If this lesson helped you, hit like and subscribe and grab my handwritten notes at EpperlyNotes.com, which are all free. We're going to make calculus simple and intuitive together. Thank you for watching this video. I'm genuinely curious to hear your take on this matter. Drop your answer in the comments below and I'll be down there reading and replying. Thank you for watching, and I'll see you in the conversation.